Hey, hello, hello. Man, if you got through that C and D homework, this thing is all downhill. It's like a backcountry skiing. You're like, oh man, I don't know if I like it. And then all of a sudden, you get to the top and whoosh, fresh powder. Everything's great. Life's good. Food tastes super. So, I think you're there. Today is kind of fun because there's nothing too crazy about it. We just got to rock and roll. Hey, we're going to actually now use logarithms to solve these equations. What we're used to before, when everything's all peachy and perfect. And in math books, they give you problems that look something like this. 2 to the x plus 3 equal to 32. And you're like, wow, I think I can get that. But if you're smart, you can put things to the same base. 2x plus 3 equals 2 to the 5th. And whenever you have the same bases, bam, you can just get rid of those, and you're like x plus 3 equals 5, and subtract 3, and you get x equal to 2. Mr. Sayers, I'm smarter than that. I could just look at that original problem. Yeah. That's why I'm so lucky to be around you guys. But the point is, sometimes finding that the common base isn't the easiest thing. Hence, example number 1. We're going to find 2 to the x. We have an equation 2x equals 30. We're going to find this exactly. All right, now, please check this out. I think the cool thing about mathematics is there's usually a couple different ways to do it. If you figure out one way and stick with it, great, probably works, but man, be open to the different. So I would say the first maybe way to look at this is that thing is down to the exponential mode. If I just put it in the equivalent logarithmic mode, maybe something will present itself. So that is log, the base is 2 of 30 equals x. Whoa! In one move, I got it. One move, I got the answer. That's exactly right. I think you're thinking about last year, maybe, oh, how do I evaluate that with my calculator? I don't want to. The word exactly is clearly written, which means you leave it alone just like that. But Mr. Sayers, last year, I remember if I have an x, I need to take the log of both sides. So I'm going to do the same problem. And this time I'm going to take the log of my base that I want. Maybe base 10. So log of 2 to the x equals log of 30. What I do to one side, do the other. Life's good. Oh yeah, law number 3. If I have this exponent up here, I can pull that out front. And I can illustrate that, of course, in red. Ba-boom. Right? So, that's going to be x log of 2 equals log of 30. Now remember, log of 2 or log of 30, those are numbers. So just to solve for x, you get log of 30 over log of 2. Now you're done. This is where people go and do some crazy stuff. They write log of 15, or they are like log of 28. Remember, there's no form that has a log over log. We can't like do division or subtraction or anything like that. That's finished. I think what's kind of cool though is what it's saying is log of base 2 of 30 is the same thing as log base 10 of 30 over log base 10 of 2. So that's the change of base from last year. We are not actually going to do change of base in this section, but it certainly shows up that we got x to be equal to both of those, therefore they are equal. Maybe that helps you with that. All right, find x exactly. We've got e to the x equals 30. So e is a base that we're going to want to be really confident in, and it really should associate to natural log or log base e. So I'm going to rewrite this in logarithmic form. So that is log base e of 30 equals x. And of course you don't write log base e, you write that as natural log of 30 equals x. And you're done, you're finished, that's exactly right. So over here on part B, I'm just going to illustrate, you can definitely take the natural log of both sides right now and work it out, but it might be nice to clear everything out first. So I'm going to get rid of that 3 first. So e to the x over 2 equals 7. Now it's a great time to take the natural log or the log of both sides or put it in logarithmic form, whatever you want to call it. That is going to be the natural log, so that's log base e, of 7 equals x over 2. I'm just using the equivalent forms from last week. Boom, multiply by 2, and I get 2 natural log of 7 equals x. And you're taking the SAT, you're like, sweet, I've got this. And that is not an answer. And what they do have maybe is x is equal to the natural log of 49. Maybe that's one of their solutions. So they're just saying, hey, do you remember that any number out front can be the exponent of that? So 7 squared or 49. All right. I only have 2 more examples today. Sorry about that, but all right. We've got p equals 200 times 2 times 0.04t. At some point when we use these exponential functions, I'd love for you to kind of know there's so much information given here. Maybe the initial amount is 200, maybe $200, maybe 200, we could do biological, we can do all these different examples, but the initial amount would be 200. The 2 here is like doubling. Hey, we're doubling something. So the 0.04 has a lot to do with how long does it take for some things to double. It's kind of cool. You can change all this stuff around. Anyways, rearrange the equation so that solve for t. So we don't worry about p. We're going to solve for p or for t. First step, write the problem down. Like I said before, the numbers out front of the base here, I like to get rid of. So I'm going to write that as p over 200 equals 2 to the 0.04t. Now I've got it to something to a power. When I get it like that, that's where I'm either going to take the log of base 10 of both sides, or I'm going to take the log of base 2, and rewrite it in exponential. So there's 2 ways to do it. I'm going to take the log of both sides here. So the log of p over 200 equals the log of 2 to the 0.04t. Sweet. Let's keep going. We're after the t. Since this is an exponent, we can write it out front. 0.04t times log of 2, log of p over 200. You just do one step at a time. You're fine. I'm going to divide both sides by log of 2. And finally, I'm going to divide both sides by 0.04. So I get log of p over 200 over 0.04 log of 2 equal to t. Hey, great exercise to kind of say, hey, do you know how to manipulate things? Do you know how to take the log of both sides? Once you do, the whole purpose is to get this kind of out front. So then now we can add and subtract. Oops. I believe there's something more. Oh yeah, find the value of t when p equals 6. So that just means plug in 6 and then use your calculator. That's it. So when p equals 6, t equals boom. Since it's log base 10, and that's why I chose to take the log both sides because I knew we'd evaluate it, I can use my calculator. All right. This is definitely the next level. It's using this forum to kind of introduce almost a different topic. So I'm going to go for it. Man, you've got this, but it's all about that negative exponent as 1 over. So we'll see. All right, find algebraically the exact points of intersection. We've talked about intersections like lines and parabolas, stuff like that. The key is set them equal. So we will set e to the x minus 3 equal to 1 minus 3e to the negative x. All right, solve algebraically. I've seen so many cool attempts here. Maybe take the natural log of both sides, but these aren't being... So let's kind of put a few things together. So let's get it all on one side. E to the x minus 4 plus 3e to the negative x equal to 0. Now, I would say a lot of people are going to be like, I don't see it. But I'm going to give you kind of an analogous look. And I just want you to try to trigger it instead of like, ooh, I'm going to tell you. What if I had, let's say, y minus 4 plus 3 over y equal to 0? I would hope that you notice the y's on the bottom. Maybe I don't want it there, so maybe I can multiply everything by y and it would clear that out. So I get y squared minus 4y plus 3 equal to 0. And maybe that's a quadratic that we can solve. All right, back to this bad boy. Believe it or not, that e to the negative x can be written as e to the x minus 4 plus 3 over e to the x. You're not going to see that in the books. They're going to kind of assume that you see that, you don't need that. But for me, it triggers that maybe I multiply everything by e to the x. So here I'm going to get blah. I am struggling mightily. So I'm going to multiply everything by e to the x. So this is e to the x squared minus 4e to the x plus 3 equal to 0. That's a quadratic. I know, you're like, no. Yeah, I've got something squared minus 4 times that something plus 3. Sometimes you're going to rewrite this as e to the 2x minus 4e to the x plus 3 equals 0. I know you're fighting me a little bit, but you got to admit, you take an exponent to an exponent, you multiply them. But you still notice this as a quadratic. That's like the new thought in this section that they kind of throw at you. I'm not going to avoid it because it's super cool, but it is kind of new to you. Hey, how are you going to solve something like this? Just like you would with anything else. You factor it. So it just turns out that I can factor this. If I take e to the x and e to the x, two things that multiply to positive 3 and combine to negative 4 are minus 1 and minus 3. And then I've got two equations to solve. I've got e to the x minus 1 equals 0, or e to the x minus 3 equals 0. E to the x equals 1, e to the x equals 3, and we get back to really the first problem we did, and that is, how do you solve that? Well, log base e of 1, so natural log of 1 equals x, and natural log of 3 equals x. There are a few things that you have to memorize, and that is the log of any base of 1 always equals 0. Because what are you saying here? You're saying b to the what is equal to 1. Well, the only thing that makes that 1 every time is when that is 0. Okay, so I can say 0 is equal to x, or the natural log of 3 is equal to x. That's only one example. You're going to have a few to try tonight, and I'll certainly help you out. Under 15 minutes. Well done, Mr. Sayers.